before I blob something. ENI OEM-1250 series RF plasma generator. This system has a digital display of the forward power and reflected power, and the system could be interfaced through a 25-pin connector for remote control. Right now the pin number 10 and 23 are jumpered on the connector to enable the generator, and I have connected a chiller, an in-house water cooler, to connect it to the system. The system generator needs at least 3 liters per minute water at about 20 to 25 degrees Celsius. The temperature of the water should not exceed 35 degrees Celsius at any point of time. The power requirement of the system: it can accept 3-phase 50 or 60 Hertz AC line between 180 to 242 volts line to line voltage. This is conforming to the US standards. The voltage between line to line should be approximately 220 volts, or not less than 180 volts and not more than 240 volts AC. That is between line to line voltages. I have connected a resistive 50 ohm load to the generator output, and I have a Bird watt meter which is good for 2 to 30 megahertz frequencies with about 2500 watt slug in it, and by rotating the slug direction I can measure both forward and reflected power going from generator to the load. Before turning on the power to the system, I'm turning on the water cooler. And then the generator is on. So the initial screen shows in normal mode, and in order to turn on the RF, press the on button. The output will show up. To increase it, use the up arrow button, and so this is about 634 watts. I have a 2500 watt slug here, and it is about the same in the analog meter here. I'm going to ramp it up to 1000 watts. The meter tells 1000 watts. 1000 watts, the reflected power is almost 0, but the digital meter indicates about 2, which is conforming to the specifications of the system. I'm ramping up to the full power, 1250 watts. A user manual will be included with the machine, an ENI operation manual for instructions, for detailed instructions for operating the system. Advanced Energy Cesar RF power generator. The maximum output of this generator is 600 watts. The power input to this system is 230 volts and single phase, 50 or 60 hertz frequency. The system do not require any water cooler. It's air cooled generator. Make sure that always the air cooling fan is working. There is a RS-232 port. This generator could be connected to a system and controlled remotely. And there's a diagnostics port, which is a 15-pin port. And there's a 9-pin diagnostic port and a 25-pin user interface port. Right now the system is connected to a resistive load 50 ohms using the bird meter and a 1000 watt slug. To turn on the generator, press the on. The system manual is available on a DVD, and the system output right now, the forward power is about 100 watts forward and 0 watts reflected, and the bird meter indicates the same. Now it is 200 watts. I'm going to crank it up to 300 watts. And 400. And the reflected power in watts is about 1 watt at a 400 watt forward power, which is well within the specifications. And this is a 600 watt full power. So it's various parameters on the system are programmable by pressing the program, and the parameter can be changed by pressing the change button. So you can also control the DC voltage, DC bias also. And this unit requires a specific matching network in order to be interfaced to a RF plasma chamber, which is, the details are given in the user's manual. The ENI matching network. Here's the matching network controller, MW-5, and matching network module, where the variable capacitors are inside. There are 2 capacitors attached to motors, and these capacitors vary depending on either the manual positioning of the capacitors from the controller. The manual position can be varied by adjusting the pot here, and you can see the cap moving. So when the cap is almost fully engaged, it is maximum, indicated by the LED. And when the cap is fully disengaged, the plates, it's the minimum value of the cap. There are 2 sets of capacitors, fixed capacitors. This one is about 470 picofarads inside the unit. According to user's manual, if the capacitor is fully disengaged, then we have to decrease the capacitance by either attaching a capacitor like this in series to that cap. If it is fully engaged and the output is not tuned, then we have to add extra caps in the circuit. The capacitors are numbered and the procedure is explained in the book. Also, the inductor is here. If it is necessary, the number of windings can be reduced or increased depending on the tuning condition. The control unit has a local and remote preset toggle switch. When the preset conditions are fed into the controller from the connectors in the back, then the toggle switch should be selected remote. And the tuning auto mode, the system gets some feedback of the amplitude and phase of the RF. And depending on the signal level, the tuning takes place by adjusting the capacitors to reduce the reflected power to minimum value, which will be visible on the generator, and the forward power to maximum. So first I'm going to adjust the forward power about 75 watt. 75 watts using the Cesar RF generator, and I'm going to turn on the power supply. Right now the reflected power is about 58 watts. I'm manually tuning it. By manually adjusting it, the reflected power is reduced. The current setup is not exactly a process setup because I'm using a dummy load. This setup is only to demonstrate that the matching network controller is working. So now I'm going to set the tuners about mid-range, and now as soon as I turn on the power, the tuner positions the caps in auto mode so that the reflector power is minimum. The reflected power should be almost zero or as low as possible when the tuning network is connected to an actual process chamber. This tuner is good up to 500 to 600 watts of RF power. And it's always important to properly shield both the units and ground the chassis, and the hot RF leads should be properly shielded or insulated to prevent any kind of electrical shock. The matching network module has a 25-pin connector through which the power is supplied to the whole system from the controller. From the 25 pin connector is on connector J4. The other connectors here are optional when signals from the RF generator are to be interfaced to the matching network controller, so that either the generator can be controlled or the signals, the forward and reflected power signals, could be monitored on the matching network meters on the front. The same meters are also displaying the position of the capacitor 1 and capacitor 2.